Hello, my name is Cheddadi, and I am a PhD student at Cairo University SFC in Japan. Today, I will be presenting my research paper titled Exploring the Self-Organizing Structure of the Moroccan Medina, a simulation model for generating urban form. This presentation is in 5 parts. First, we will be discussing about generative urbanism theory. Next, we'll be defining and reinterpreting the Medina model. And then we will be discussing generative design simulations, which will lead us to our experiment, which is an urban simulation. And finally, we will be having a small discussion. This research explores the use of generative design and evolutionary algorithms in the exploration of high-density and low-rise urban morphology. Based on the study of the urban form of ancient North African cities known as Medina, a set of generation rules, functional constraints, and objectives are defined for an urban simulation model that reinterprets its characteristics while aiming for diversification and adaptability of the urban morphology. Generative urbanism understands the city through generative rules and processes of growth. It is a way to rethink how cities are designed in a non-hierarchic way through bottom-up and the use of patterns. Before the 20th century, many urban developments predating urban planning were generative and adaptive by default. Nowadays, it is much harder to find an example of generative urbanism. Medina cities are all Islamic cities of North Africa. They are known for their high density and labyrinthine street layout, and can be described as examples of generative urbanism. From the 1970s onwards, many studies have emphasized on the understanding of these cities through their social, cultural, and structural systems, including generative urbanism theory. From these studies, we summarized 3 main guidelines to interpret the Medina model's generative systems for contemporary developments. These include morphology, organization, and community. To achieve this, we will be using generative design simulations as a means of experiment. The advent of algorithmic and parametric design and their wide application in the fields of architecture and urban design has made it easier to run calculations that can simulate and optimize an urban form to multiple factors. Generative design simulations are tools that generate morphologies by formulating, evaluating, and generating morphological outputs. For this simulation, we use Rhinoceros 3D and its parametric design plugin Grasshopper. We also use a computational solver called WallaceyX with a parametric design methodology, including multiple inputs in order to generate, rank, and visualize urban morphologies. The computational solver that we use is a multi-objective optimization evolutionary algorithm. It comprises of 4 steps with an iterative mechanism, going from formulating, generating, evaluating, evolving, and finally selecting outputs. To formulate the generative simulation, we modeled a generation rules that allow for introverted urban blocks, high density, and non-linear layouts. The optimization solver is set with conflicting objectives that are higher urban density, better sun exposure, and higher connectivity. Comparison of the evolution of generation results is done using the Pareto frontline. We can find a trend for optimizing the urban form while keeping diversification. Exploring the Pareto front with its respective data allows to visualize the candidate solutions and comparing any physical discrepancies between the results and with the visual forms. Any solution with a specific rank for a fitness criterion for any objective can also be selected and reinstated. This study has shown that combining generative design with morphological characteristics of Medina-type cities in an optimization simulation can offer a diversity of outcomes, adaptability to constraints, and flexibility in generative rules. However, the non-permeability of proof checking, which means that this model cannot be proof checked by external factors, is one of the shortcomings of the study. As prospects, we are aiming to explore the use of different algorithmic designs, strategies, and experimenting with cellular automata and agent-based modeling. Here are the references for this study. Thank you very much.